Hello folks, in this video I would like to show how we build the vertical wind turbine, namely the work with wood, the work with styrofoam, and the actual assembly. In previous videos I showed how I built the generator. That's why I won't show it here anymore. Here we see the wind turbine turning in the wind. It consists of an outer wooden frame in which a vertical rotor made of styrofoam rotates, which we have reinforced with a glass fiber cover. The framework consists of boards that always direct the wind to the right side of the rotor. So it doesn't matter which direction the wind blows from. It always hits the rotor blades at the right angle. Here's an impression. The advantage of such a vertical axis compared to a horizontal axis is that the wind turbine does not have to be tracked in the direction of the wind. Wind from every direction drives the wind turbine. It is therefore very suitable for places that have a lot of turbulence, where the wind can change direction quickly, for example, near buildings or other wind obstacles. Although the wind turbine is temporarily set up very low on a trailer, it already rotates powerfully enough for the wind generator to charge a car battery. With the light wind, the generator supplies around 6 volts of alternating voltage. But with the voltage doubler and rectifier that I show in another video, the voltage is high enough to charge a 12-volt car battery with DC. Of course, it would be better to set it up higher, somewhere where the wind is stronger and the wind turbine is more exposed to the wind. But it would also work in a canyon of houses if the wind blows right through the gap between two houses and hits this wind turbine and drives it. Of course, the voltage increases as the wind increases. Here we see more wind means more energy. But let's go back in time and see how the wind turbine came to be. This is the form of the wind blade, and I made it with the help of this. And how I did this, I will tell you now. So first draw a circle, then decide how many blades you want. I would like to have 3, so I divide the 360 degrees by 3, that's 120 degrees. Then draw tangents to it, here, here and here. And now you can paint the wind blades. Starting from one tangent, you draw something like this, and it has to go into the next tangent. Once again, out from the tangent, into the next tangent. And one last time, out from the tangent, into the next tangent. So now you have 3 pieces. This is important. From these 3 pieces, choose only one. Choose the one that you like the most beautiful one. Cut it out and make a copy of this so that you have exactly 3 identical pieces. Make a small hole in the center of all 3 copies and insert a small needle through it. And then you arrange the 3 copies exactly so that the points come together here and here. You stick these together with Scotch tape, and then you have a beautiful wind turbine with 3 completely identical blade shapes. When you've got this shape, you can then cut it out like this, and do not forget the middle point, the center, because later if you forget it, then you have to guess where the center is, and this sometimes gives a bad rotation when this thing spins very fast. So don't forget the center. And then cut it out. I have prepared it here. Then you put this thing onto the styrofoam and you mark the edge like this, there, and don't forget the center, like here. This thing is only to hold it in place with some weight. Then it looks like this. And now you can start to cut it out, or better say, melt it out with this machine. Now we have a nice shape, but the hole is missing. We need a hole in the middle to put it on the axis. So the question is, how do we get this hole into it? We can't use the hot wire because it would cut from here and damage this thing. So we need to do something else. I think maybe we can try the drilling machine. But first I will try on a piece of trash. Leftover styrofoam. Let's say I want to hit this. As you can see, it produces a lot of trash, and it didn't go through because it is not long enough, and I didn't even hit it correctly in the center. It's hard to hold this drilling machine in place. Maybe we could do this hole from the other side, I don't know, but I don't like this. I think somehow we have to think about something more elegant. Let's see what we can do about this. As you can see, we did quite well. So this was for testing, and the tests were quite good. So I think we can really start to melt with the original wing form. So how did we do this? We thought about this machine. We invented this little thingy. We've got here two iron or steel profiles, and they are holded by two screws over there, and they are about 2.5 meters long, so it's quite long. And the thing is, you can move them on this side, and because there are two of them, this thing stays always parallel, so it doesn't go this way, it just goes this way. It does change its position, but only very little, because the steel profiles are so long. So when you play with fire, you have to be cautious and have something for security. So we've got a fire extinguisher on the one side and a bucket of water on the other side, so we are safe here. So now we are gonna melt a hole into this. First we have to find the center. So the center is found. This goes away. Now we have place to make the thing hot. And once it's hot, it has to happen very quickly. And yes, let's see. Very good, nice hole in the center. Now we can put these pieces together onto the axis. Now we glue the pieces together. The windmill is now drying. Our wind turbine needs an axis. We've got this aluminium axis, but we can't weld aluminium, so we decided to use steel. Steel is more strong anyway. So we've got this steel tube, and here we have a steel plate. We drilled 4 holes in it, so we can put screws in it to fix it. And we welded one piece to the other here. And then we made the plate that is rotating, it's round. Let me show you this. We tried to make this round plate with a circle, but the circle was too small. So we thought about how can we do this, and we did it with a little trick. You just put a nail in the middle of where the circle shall be, then you bind some wire to it, and on the other side of the wire you bind a pen, and then you can make a beautiful circle. Then you can cut along the mark till you have the circle cut out. And then you need to drill the hole where the axis is going through. It's in the middle. We used a drill for wood to make this hole. We can fix it with screws, 4 screws, and then we can put the bearings onto it. Like this, here, with the bearing inside. We can put it on the axis, and we can fix it again with screws to the housing. Yeah. So we've cut out this ground plate. It has a shape of a square. It has 4 corners. To make it a little bit more interesting when you look at it, we will cut these corners, and we will then have not 4 but 8 corners. So let's start. So the upper and lower boards are ready. You can see them here. Inside is the bearing. And we drilled some holes into it where the screws will hold these pieces all together. And we used this machine here to smoothen the edges so it's not so sharp anymore. It's more safer when you touch it. And that's the upper board. From the other side, we drilled from the other side bigger holes so the screws can hide inside and it looks smoothly. We did this with the edges, with the boards too, like you can see here. 8 pieces, and they are all cut with the same size, so they will fit to the boards with the same size. So now let's put these pieces all together. That's how we build together the rotor. You have the axis, you have this wheel, and you put the wheel onto the axis like this, and you simply fix it with screws. 1, 2, 3, 4. Then comes the distance piece, and then comes the bottom plate of the casing with the bearing onto it. Similar on the top side. First the styrofoam, then this wheel, glue it together so it's thick and it holds. Then this piece, again screw it together with screws, and then the distant piece, and then the bearing of the top plate. We really tried to make this lower and upper rotor blade as much as a circle as possible. But as you can see, it's not really a circle. When you look at the distance here and I start to turn it, you can see it's not really a 100% circle. You can see the distance is varying. So we will try to make it more round with this tool here, and cut away a little bit of the edge so that it becomes more of a circle as it is now. We tried to make it more round, but we ended up make it more unround. This machine went through the wood into it at a place where it shouldn't go into it. So it's now more unround than it was before. So we built this thing and we screwed it with screws so it's stable. It cannot move, as you can see, it's stable. Now we hope that this machine is not going into the wood anymore and it stays stable, and then we will be able to make it round again. We did it. The wheel is round, like a circle. Look at this. The last time we draw a circle, it wasn't really a circle. It was a near circle, but not really a circle. So this time I'm not using a wire, but a more stable piece of steel, where I have bound a pen to it, so that I can draw a circle. We've put a mark on it so we can see later how we can put it back on so that it fits us as it was before. We opened the back door and the front gate in the garage to let the wind come through. And now look what happens. Is it cool or is it cool? The casing for the windmill is made from wood, and wood needs to be protected from moisture, from rain when it stands outside. And to make it weatherproof, we can use paint that is used for boats, for wooden boats. Before we start to paint it, we need to prepare it a little bit. When the wooden planks are uneven, then you can use sandpaper to make it more plain. And even if your wood is dirty, you can remove the dirt with the sandpaper. So when you have prepared it, you need to stir the paint. So. And then you can start painting it. It's clear paint, so the beautiful character of the wood is preserved. The epoxy dissolves the styrofoam. To avoid this, we need to lay a layer of paint. This is latex paint, and then the epoxy cannot reach the styrofoam and cannot dissolve it. That's why we are doing this. So this is the rotor after we have covered it with fiberglass and epoxy resin. As you can see, it didn't work out well at all. The problem was that the epoxy went through 2 layers of paint which I have put onto the rotor, and dissolved the styrofoam. And as you may see here, inside of it, is almost no styrofoam left, only at the bigger parts. The epoxy was just too aggressive. It dissolved it here and there completely. That's very bad. I doubt I will ever build a rotor from styrofoam again. Well, that's how people learn, by doing mistakes. Okay. So, I want to show you something else. This is the wheel of the starter where the coils will go on to. And this is just a round shape with a hole, and I have marked where the coils need to go. Well, yes, and then the windmill together with the generator were done. We are finished, we are ready. It was a big project. I spent a lot of time doing it, but I had a lot of fun. I learned also a lot about generators and windmills. And if you enjoyed watching it, then give me a thumbs up and let me know in the comments what you did like. Thank you very much, and maybe till another video. Bye!